Hello, welcome to the next episode of the RX Workshop. Today we'll be talking about how to use schedulers in order to distribute queries to places like remote machines or also to things like Azure. So we know that RX is observables, link, and schedulers. Today's episode is focusing on the scheduler aspect, but it also, of course, integrates with the other two, the link and the observable part. So here we have a machine and some remote place to execute things. We'll just call it cloud throughout this episode. So previously, all of the queries we've done have executed on the local machine. We've done things in other threads and in virtual time, we've executed things there, but we haven't executed things like across the wire. And so we'll see kind of the challenges that introduces and what RX does in order to solve those challenges. So here we have the local machine, we have a query, and now instead of executing it locally, what we're going to do is actually ship the query over to the cloud to execute it there. And what we want to do then is actually stream the results back to the person that originated the query. So how do we do that? Well, here's what we'd like to write. We'd like to write, create a timer, for example, have it fire every second, but now schedule it on Azure. And then we'll say observe it locally and then subscribe. Now, if you squint, you can see that this is actually very similar to what we've done previously. Previously, we've done things like, observable timer and have a time span with, 1 second, but we said like some new thread or the thread pool. And then instead of saying observe locally, we said observe on the dispatcher. But really it looks pretty much the same. We're saying we want to execute it somewhere else, and then we want to observe the results now locally. And so what we want this to do is to execute the first part of the query on the cloud and the second part, the subscribe part, locally. So we stream results back. We send this to the cloud, and then we send the results back. All right. So there's two basic ways you can pass values in distributed environment. You can pass by value, by marking things as serializable, and you can pass things by reference, as marking them marshal by ref. And what we want to do with the distributed scheduling here is we have X here that we're closing over. So we want to schedule maybe on this remote scheduler to write something. But how do we schedule it so that it passes X the correct way? Is it passing X by value or by reference? Is it using it as marshal by ref, or is it serializing it across the wire? So what happens is that what the compiler does is it actually generates a closure here. And that closure it contains X and also contains some method that represents the lambda. And so when the code actually runs, it actually constructs the closure, assigns the X the value, and then invokes schedule with the closure's M method. And this is really what happens underneath after you compile your code. Unfortunately, though, we didn't mark X as either serializable or the closure is marshal by ref. So it's like, well, how do you pass it? Do you pass it by value or pass it by ref? So closures are kind of a problem when you go across boundaries. And you'll see this again and again if you look at how to use link in distributed scenarios. Okay, so what we need to do is we look at the scheduler interface. So previously, we showed you the scheduler interface. All it had was an action of T work and return back a disposable for canceling things. Some people noticed in that episode that that's not actually the interface that shipped. So today we'll be describing how we actually derive the full interface from the simpler one, because conceptually, all we needed was the one we showed you previously, but now we're going to show you why we actually have the full interface. So here we have a schedule method, and now it takes a T, and the T is the state. And so now you can explicitly pass in the things instead of closing. So in the work, what you want to do is you want to make sure that work closes over no variables. If it does, then it's ambiguous again, whether it's passed by reference or passed by value. But now you can pass in the things you want inside of state, and that part can be marked as serializable or marshal by ref or some combination of the two. And so you can be explicit about it. So back to this example. So instead of taking X as in a closure, now we pass it in as the state parameter and we pump it through. And what we can do is, what we see now is the compiler actually generates different code. It generates an M method, but it doesn't have like this closure thing. And so now we can mark X as being serializable, and off it goes. Okay. So now the next thing is that we want to schedule things after scheduling. So for example, when you do observable.interval, it's actually repeating timer. And the way it does that is it schedules a timer to occur. And then once that timer completes, it pumps out the message and then schedules another timer to occur and so on. So it's very common to actually do these kind of nested scheduling operations. And so now how do we do that? Here we actually have scheduler twice. We have it outside the lambda and then inside the first lambda. But now we've closed over a value, in this case, the scheduler itself, which seems like a bad thing because we don't know how to pass it by value, pass it by ref. And even if we did, what would it exactly mean? Because what we want to do here is we want to send a request to do work across through the cloud into the scheduler, and then we want to repeatedly do work inside of the scheduler itself. We don't want to bounce back out and then bounce in.
Back to here and then schedule back in.
Exactly. That would be bad. That'd be terrible, right?
Yeah.
Because imagine you wanted to have a timer that would, in the cloud, into Azure, and then you schedule work in Azure, and then it executes, and then it bounces back out in order to do the new one. It would take forever, and you couldn't do the right thing. So you actually want to repeatedly work within this box. You want to have the first schedule operation jump inside the box, and then you want to keep working inside that box, which is the scheduler.
You need to have access to the scheduler itself.
Yes, the local version of it. The local interpretation of it. And so what we do now is we change the interface again, and we actually pass into the work an iScheduler value. And that iScheduler represents the local version of the scheduler. So now what we can do is, instead of using scheduler here, we actually use S, which is the scheduler, but the inside the box version, how to reschedule once you're already inside the scheduler. And so that allows us to do kind of like these nested schedulings. So for example, we can also fan out here. So each time, for example, we might schedule work that jumps inside of a scheduler and does a bunch of other work, schedules things, but then it may also schedule on some other scheduler, and it keeps going like this. And now the problem is how do we actually cancel this whole tree of computation, right? So previously we kind of had all work done within a single scheduler, so it's pretty easy to track this. But how do you compose together the cancellation? Well, the way we want to do this is we want to schedule things and then grab the disposables from both of the inner schedule items. And but how do you actually now pump that on the outside? How do you get it back out again? Because we can't pass it out by...
So if somebody disposes D,
yes,
the endpoints need to be disposed. So
exactly.
How do you tie the things together?
How do you tie it all together? So here's what we do. Now what we're going to do is we're going to change the schedule operation, instead of being action, to return the disposable. And the disposable represents all of the work you want canceled if you are canceled yourself. So the work that's dependent upon you. So here we change the code now. We have D1 and D2, and now we want to tie it together with D. And so what we do is we just return out a composite disposable, which is a combination of the two disposables of D1 and D2. And so now when you cancel D, it will stop the work represented by the lambda as well as D1 and D2. The last thing we want to do is we want to be able to do recursive scheduling. So actually when I mentioned the interval timer, it actually is a case of recursive scheduling where it continually schedules itself. So yes, it's scheduling back on the same scheduler, but it's actually a special version of it where it's always executing the same body of code. And in those cases, what we actually do is we have extension methods on top of the scheduler interface that take a self parameter. The self it looks kind of strange. It'll be like action of T would be an example of that kind of the self parameter. So the type of this thing would be action of T. So what it means is, that when you invoke self, it'll actually execute the same body of code again. Okay, it schedules it to be executed again.
So yes, some overloads take a time span as well, right?
Exactly.
That's all the timer uses.
And so that's how you do recurring timers. So you'd schedule it once, and then you would invoke self with some state and then some time, and then it would reoccur at that point in time. All right, and then one note is if you want it to only occur one at a time, what you would do is you would actually make it sure that your function is tail recursive in a sense, so that you invoke self at the place you would normally return from the function. And then it works out just right. All right, so I think we're going to look at the demos now.
Yep. Okay, so let's take a look at how some of the operators really are written with this, scheduling in mind behind the scenes. So how would you write assume that you have a Windows Azure scheduler, how would you actually write an operator that generates like numbers in the cloud, in a right recursive way so that you can cancel it and all of that stuff. So let's take a look at how an operator like, observable.range would be actually built. So pretty close to the range operators
Let's do
implementation.
return,
Or
actually.
return.
Let's do return.
Yeah, return is actually simple enough, I guess. Yeah. So let's do return. And so the way you would actually build a return, well, actually, let me make a generic in t value, is you need to generate a sequence that basically fires out the value and then fires out on next, on completed, I mean. So the naive way to actually write that, and I will also pass in a nice scheduler to say where the value needs to be produced. Actually, I will need to include Rx to begin with. That would be a good thing. Let's include system reactive. So now that I have the iScheduler, that's the place where we actually wanna run the work. So the way to do that would be something like this, like in the naive implementation. You would say, I'm going to create an observable sequence using observable create of t, which actually gets passed in the observer on which we actually wanna, pump out values to the user. And so the thing you could do inside here is something very naive, like observer on next of value, and then observer on completed. Now, in this case, we also need to return the way to unsubscribe, and I don't quite know what to give to the user here to prevent this thing from happening. Like, the user can't unsubscribe from that thing because, well, this code is actually running sequentially. So like this implementation is really not the thing that we want to use, and we also have a problem here with the scheduler, in a sense that we're not using it at all. So we haven't parameterized anything. So the next thing you would actually want to do is like scheduler.schedule, and then you would like to pass in an action that basically indicates the context on which we're going to call on next and on completed. So that's already getting a little bit better in the sense that I can say where to do observer.onNext, observer.onCompleted. So now I've already moved to another place. So I could call return here, given a new thread scheduler or an Azure scheduler, and that would basically run this block of code somewhere else. Modulo a couple of problems that we have. But let's
wire together the cancellation.
Let's wire the cancellation in at this point. Like scheduler.schedule returns an iDisposable that when you call that, the scheduled action can be withdrawn from scheduler queues and those kind of things. So we can already wire up the cancellation here simply by returning the disposable that comes out of the scheduler. So at this point, we already have cancellation kind of working. You can call dispose and it actually tunnels back to the scheduler to cancel this body of work. Now the problem is that we have closed over both the value and the observer here. Like, we don't quite know, like, if the scheduler really goes across networking boundaries, for example, how the value needs to be passed into the cloud and how the observer needs to be passed in so that we can tunnel, values back to the client. So we have a number of issues sitting here. So let's first of all address the issue of the value being passed across boundaries. So passing the value across boundaries would be something you can do by passing in the value here, and then actually you will get an overload sitting here that takes in the t, which is the state, which is now the value, and then we have this action that actually can get his hands on the local version of the scheduler, which we're not using here because we're not recursing, as well as the value that was passed in. So I can, get my hands on the scheduler and value underscore, which is the value that got serialized or marshaled across boundaries here. So now I can actually call observer on next of that value underscore. But the only thing I have to do now is, like, from the schedule method, which actually has the signature of a function iScheduler t and iDisposable, I need to return, all the work that sort of was recursively done there. In this case, there's no work that's recursively done, so let's actually go for a trivial implementation again in this part.
Could do disposable.empty.
Or disposable.empty, which is actually the stub for exactly this. Disposable.empty. So as I do that, now we're basically scheduling on the scheduler. We're passing the value explicitly into that, remote box, and we can actually put our hands on value underscore. Now I will want to do something very similar with the observer, like how do you pass things back out to the user? So you would actually have to wrap this observer in something that's like marshalable across boundaries to actually send messages back.
And we actually have the remote operator for,
yes.
I think in the experimental version, right?
In the experimental version, we have a remotable operator that actually does that.
Yes.
And actually I've included the 1.0 version, which is the stable version, so I don't really have that operator sitting here. But the thing you would do is you would basically send the value as well as the observer, the remotable version of that to the scheduler here.
That's right.
So you would create some little wrapper type that contains both of those guys. Now inside this box, I could actually schedule things recursively. Say that I also want to send out to the user, like for example, value +1. I would do something like s.schedule, and then I would schedule in there the action to be done to actually pump out value +1. So I could say in this particular case, pass in value _+1. Then, I get yet another copy of, the local version of the scheduler, like I'm just, recursing here. I get, value 2, which is like the value +1 thing. And then here I could do the observer on next kind of thing. So we're basically just, getting one level deeper into this whole contraption. In here, we can actually return disposable.empty because there's nothing to be done to actually dispose this thing further. But now the thing that you actually get out of s.schedule is now disposable, which you could actually return from the outer one. So basically you're wiring through the entire chain of cancellation all the way to the leaf nodes of the computation. And if you would have multiple of those guys, you would of course create a composite disposable and so on.
That's right.
So that's essentially how some of those operators like observable return are written. It's basically by passing things explicitly to the scheduler and then basically calling the observer to pass data out.
Should we look at the challenge?
Yeah, let's take a look.
So one thing to note is that Rx today, the operators that are included, don't have this transformation as of yet. That's something to look for in the future. But if you need to be able to use distributed scheduling, then you'd want to author your code the way we're showing you. Okay, so here we actually have included an app domain scheduler. So that means we're going to be scheduling things across app domains. And we use generate here, and then we say observe locally. And then we do a for each. And we want the output to look like this. And you'll see if I run this right now, that it actually does this on the thread pool. And this works just fine. The problem is that there's actually a bunch of closures. And
say the implementation of generate is sitting deeper here, right? Yeah.
Exactly. So here I've implemented a custom generate. And what you'll see is that we actually close over a bunch of things. So we close over
things like the result selector, the results, the observer,
all of this
scheduler, everything. Yeah.
And so what you need to do is actually, the only thing you do with this challenge is rewrite the subscribe method in such a way that there are no closures. And when you've done that, then you should be able to go to the top and change scheduler.threadpool to
the scheduler.
And now if I'm going to run this like this, it will totally crash on me. But if you do it properly, it'll actually pump out the same output.
And the cache you're seeing is actually a serialization issue of closures that we're actually heading there. So.
Exactly. So have fun. This one is a challenging challenge. And if you do this and understand it, then you'll understand how to distribute code using Rx or anything else that has kind of like this functional design. Thank you, and we'll see you next time.